All right, guys, I want to go back over something we did back in ICP number 5, the in-class problem number 5, the grapefruit toss. I want to combine now, we're starting to get into antiderivatives, and um, I want to develop a formula that we use for that problem and to show you where it comes from. So one of the situations, the initial problem, let me put it onto the iPad. The initial problem was that the grapefruit was tossed straight up. So it was tossed straight up, and the initial velocity was 32 feet per second. That situation right over here. And it was released from 48 feet above the ground, the top of a building or something like that. But anyway, so the initial velocity, V sub zero, was 32. The S sub zero, which is the height, the distance formula, how high is it above the ground? S sub zero at t equals 0, the height was 48. The initial velocity at t equals 0 was 32. All right, and I came back and I gave you this formula that S of t, the height function, is equal to negative 16t squared plus v sub 0 t plus s of 0, which came out to be the s of t was equal to negative 16t squared plus 32t plus 48. And then we took derivatives, et cetera, et cetera. So let's go through the process now of get the process of what we did. Position function is this. This is how high it is above the ground. Well, the rate of change, the derivative, the rate of change, slope of position is how fast is the position changing, which is velocity. So it turns out that if you take the derivative of s, the position, you end up with v. All right? And then what if you take the derivative of that? You know? So we're talking about s double prime now. That is, what's the rate of change of the velocity? How fast is the velocity changing? That is equal to the acceleration. So we've got these relationships that are over here that are kind of significant. The derivative of position is velocity. The derivative of velocity is acceleration. So take a look at this now. Let's start with acceleration due to gravity. And this again, this is talking the English system, so we're talking feet per second, all right? And gravity in feet per second is equal to negative 32 feet per second, and it's acceleration, so it's changing the velocity at 32 feet per second. That is acceleration. Gravity is that. This is A of t is equal to negative 32. That's the situation. A of t is equal to negative 32 feet per second per second. All right, now, so what's the reverse of that? Notice that it comes from the velocity, the rate of change of the velocity. So to get a formula for the velocity, we've got to go back one step, which is the antiderivative. All right? And what is the antiderivative of a constant? So the antiderivative of a constant, the reverse of the acceleration is the velocity when you go in this direction. So velocity, you've got to do the inverse of this situation is equal to, notice what you've got here. You've got, what is the antiderivative of negative 32? A constant. You attach the variable to it, right? And we've also started getting the hang of the fact that you also don't just have that value. It's possible that you could have a constant that was added to it. When you go from velocity back to acceleration and take the derivative, you could have plus c all over the place, okay? And it turns out that that c is the initial velocity. The initial velocity affected by negative 32 times every second that it's in the air. So gravity is having the effect of negative 32 feet per second knocked off from what you initially start from. All right? So you start off with initial velocity, and after 1 second, you end up being at, subtract 32 from that initial velocity, and that's where you'll be. So this ends up being, and it turns out we were given in this problem, the initial velocity was 32 feet per second. It was being thrown up at 32 feet per second. All right? So after 1 second, the situation was, after 1 second, 32 is taken away from it, the velocity's down to 0. That's what's happening here. It starts off at 32, and then gravity, every second, is knocking off 32 feet per second. All right? So it turned out that that ended up being the situation we contended with. The answer to the question was, how long did it take to reach its peak? When was the velocity equal 0? It turned out to be 1 second. All right? So it turns out that if you set this function here equal to 0, you know, take the 32 across, then you get 32t equals 32, and t equals 1. So in 1 second, the t was equal to 0. The velocity was equal to 0. Now what I want to do is I want to go another step further here. So we had v of t is equal to negative 32t plus 32. Then what do you do to get the previous step before velocity? You got to go one more step here. You got to go to the position function. So you got to take the antiderivative again. So we're starting with v of t equal to negative 32t plus 32. Let's take the antiderivative of that and go up to our position function. Notice what you get. Okay, so let's use the antiderivative rules here. Negative 32t, raise the power by 1 and divide by that new power. We've got negative 32t, this was to the 1, now it's to the 2, and divide by that 2. Plus, we get the antiderivative of a constant is multiplied by a t, right? Whoops, 32, not able 2 there. All right, so we end up with 32t plus a constant, a small c of this sort. And this turns out to be, this is the position. So what position did you start in? This is s of 0. So we end up with recognizing we started at the top of a building up there. So s of t, it turned out to be negative 32 over 2, which is negative 16t squared, plus 32t, which is the initial velocity, 32, and the initial function of the height was above the ground. It started off at 48 feet. So we started with this initial function, the position function, which started with acceleration due to gravity, backed up through the constant, the constant term that was added for the initial velocity, 32, and then the antiderivative of that took us up to the position function, which is negative 16t squared plus 32t plus 48. So every time you're given a problem, if you're given the initial velocity and the position, how high it is above the ground when it starts, then with the antiderivative concept, you work from acceleration and work your way back up to the position function, which we started with. All right? So that was the situation that we were working with. And the velocity turned out to be equal to 0 after 1 second. And then also the other fact that came from this was, okay, so how fast it took 1 second to get up there. Look what we did before. If you remember this, we had a situation that it was being thrown up and it came down. And this is after 1 second. It's at the peak. And that means at 2 seconds, it was here. This is symmetrical. This is 0. 0 seconds right there. There's 1 second, and then 2 seconds, and then how long did it take to hit the ground? Well, the idea, again, hitting the ground was when is the position function equal to 0? So 0 equals negative 16t squared plus 32t plus 48. We factored out a negative 16 and got t squared minus 2t minus 3. And that gave us negative 16t minus 3 plus 1. And then t minus 3 equals 0 meant t equaled 3. And t plus 1 equals 0 gave us t equals minus 1, which is no count in the problem because you can't have negative time. So it turns out that this t equals 3 corresponds to when s of t is equal to 0, when it hits the ground. Okay? That's the general idea. So you've got the circumstance of how high did it reach? Now, if we wanted to figure out how high did it go, when did it get there? It was in 1 second. How high did it go? Well, you got to plug that back into the position function to get that question answered at 1 second. So that's equal to negative 16, 1 squared, plus 32, 1, plus 48. That equals, we've got negative 16 plus 80 equals 64. So S of 1 equals 64. The highest point was 64 feet. Then when did it hit the ground? It was in 3 seconds. We got t equals 3 seconds. How fast was it going when it hit the ground? Well, go back to our velocity function right there. So v of 3, that's when it hit the ground, is equal to negative 32 times t, 3, excuse me, there's t, plus 32.